Okay. Let me know if you can't hear it.
2 years ago, Mira Murati did something we've all fantasized about. She woke up, decided she'd had enough of her boss, and quit her job as CTO of OpenAI with no backup plan and nothing but a vague desire to create time and space for her own exploration. If you or I did that, we'd probably end up coding HTML for food down on Market Street. But when someone like Mira does it, A16Z shows up with a $2 billion investment into any company she decides to build. The company was eventually Thinking Machines, and until last week, it's been best known for being valued at $12 billion before having actually shipped anything. But that may have now just changed because they just released Inkling, a fully open weights model trained from scratch that can see, hear, reason, fine-tune, and potentially touch things in the real world. In today's video, we'll find out how it was built, what makes it interesting, and learn why Thinking Machines openly admits that it's not the best model in the world, and why that's the point. It is July 20th, 2026, and you're watching The Code Report. Last year, while the rest of us were spending time getting to know our newest team member, Soham Parekh, Mira was quietly pulling off the greatest talent heist in Silicon Valley history. When she left OpenAI, she walked out with co-founder John Schulman, VP of Research Barrett Zoff, and enough senior researchers to fill a Silicon Valley polycule. A year later, the dream team shipped Tinker, an API that lets you fine-tune open-weight models without managing your own infrastructure or losing control over the training process. When it was released, ML researchers called it cool, which I imagine was a bit underwhelming if you had just given them enough money to buy a Costco hot dog for 1 out of every 6 people on Earth. But that may have changed last week with the release of Inkling, a mixture of experts model with 970 billion total parameters. The trick is that it doesn't use all of them at once. Every token gets routed to a small subset of specialized experts, so only 41 billion parameters actually fire per token, giving you the most intelligence of a massive model at a fraction of the compute. It was pre-trained on 45 trillion tokens of text, images, and audio, handles a 1 million token context window, and unlike other open models that ship with a license written by feral lawyers from Meta, the weights are Apache licensed and sitting on Hugging Face right now. On the Trust Me Bro benchmarks, it gets mogged by Fable 5 and GPT 5.6 Sol, and lands somewhere mid-table among the open Chinese models. Now, that's not great, but the timing was even worse. One day after Inkling dropped, Moonshot announced Kimi K3, a 2.8 trillion parameter monster that, if you squint, goes bar for bar with Fable 5, and got so popular that it even burned through their compute. So in a sense, the team spent 2 years cooking up the most average model in existence, but that was kind of the point. Instead of competing on raw intelligence, Inkling has a dial called Thinking Effort that controls how hard the model cooks. Crank it down and you get cheap instant answers. Crank it up and you get Ashley Tisdale's hit single from 16 years ago, with the model matching Nemotron 3 Ultra on Terminal Bench while using a third of the tokens. And when you're running an agent millions of times per day, that adds up. And the flagship demo was pretty cool. They connected Inkling to Tinker and asked it to remove its own ability to use the letter E. From there, the model wrote its own training script, generated its own data, ran the job, then loaded its own new weights that essentially lobotomized itself. They also trained it on something they call epistemics, which is a fancy Greek word for knowing when you're full of crap. Basically, Inkling was rewarded for admitting what it doesn't know instead of guessing with confidence. As a result, it's now one of the best models in the world at forecasting future events, beating GPT 5.5 and Opus 4.8, and when it's unsure, it'll admit it. Inkling is also the Helen Keller of models, not in the sense that it's bad at laser tag, but that it can't actually see or hear, at least not in the same way other models do. Normally, images and audio get run through separate encoder models that translate them into tokens first. Inkling skips all of that and processes raw audio in pixels directly. All that reinforcement learning had a side effect though. Somewhere past 30 million training rounds, the model's inner monologue started dropping words to save tokens, going from proper English to caveman speak like, we need determine eigenvalue problem. Why waste time saying lot word when few word do trick? So no, Inkling is not going to dethrone the Frontier Labs, and Thinking Machines knows that. The real play is to hand you a mid-model for free, then charge you to fine-tune it on Tinker into a specialist that destroys your one specific problem. But if you need a specialist today to handle things like auth, billing, and user management, you need to check out Clerk, the sponsor of today's video. Your agents can build an entire app over the weekend, but if you somehow manage to get real users who want to pay you real money, you're the one stuck reading the Stripe webhook docs at 2 a.m. That's why Clerk built a CLI, agent skills, and an MCP server that let your coding agent drive of their whole platform. You can set up production ready auth, billing, and user management with just prompts. I told my agent to handle sign up and sign in, and 13 seconds later, I had auth pages, middleware, and a passing build. From there, it added basic and premium paid plans, and I never wrote a line of payment logic myself. When I asked for a list of my users, it pulled all 8 of them straight from the API. A clerk lets you go from dev to production without ever visiting their dashboard, and you can try it out for free with the link below. This has been the Code Report. Thanks for watching, and I will see you in the next one.
Okay, let's get started. Project 13. GitHub link is in the chat. LiveShare link is here. Where is Adam and I have no idea. So it's Adam and Nicholas, but Adam, I have no idea where he is. Nicholas, I believe. Okay, let's see what she said. Nicholas is away on vacation. Lucy, I have no idea. Lucy doesn't always come. Maybe she's gonna come later. Anyways, where are we? Let me share my screen. Last week we did sentiment analyzer. So here we are. We did tokenize is negated. So tokenize converts the text to lowercase, so it just makes the string characters how we want it. So we want to split the words, we want to lowercase it, remove punctuation. So we can like tokenize them so that we can feed it into our AI model. Is negated checks for negation words. So like no, isn't, etc. Score headline, basically it uses something called a Vader lexicon approach. So it basically tokenizes the headline, looks up each token, and then applies the negation and booster. So it kind of gets the kind of score of each headline of the news. Analyze ticker sentiment, we'll have to do. Oh, what happened? So we're gonna do today, analyze ticker sentiment, fetch news for sentiment, and sentiment label. Analyze ticker sentiment is basically using what we made. So we want to return a dictionary with the ticker, articles, the overall sentiment, and the etc. Fetch news, basically we fetch the news using the API. Sentiment label basically gets a kind of score for each sentiment. So if it's a good score, then it means we want to buy that stock. And I believe we'll do finish this today. So next we can, let's see, let's do analysis next, and we'll do technical and start from here, right? Okay. So Caden, can you share your screen and we'll do analyze ticker sentiment. I turned on share, so you can probably share now. Project 13. models. Okay, so let's first read the docstring. We're going to fetch news for the ticker. We're going to score each headline using score headline function. We're going to get the results. And then with the results, we're going to return the dictionary with the ticker, articles count, etc. So let's get started. So first, we want to fetch the news. So we're going to do news equals, and then we're going to use the function below it, which is underscore fetch underscore news for sentiment. It's not made yet, but basically we pass in the ticker and the limit. So the ticker is going to be just ticker, comma, limit, because analyze ticker sentiment also has that argument. If you read it, it says ticker is a string, limit is int, but above, if you see analyze ticker sentiment, the arguments, you see ticker string, limit is int equal to 10 above it. That one. Yeah. So the limit we're going to set to 10 news articles. All right. And then next line, line 2028. And the reason that's such a big file is because of the dictionaries that we preset with the negative words and stuff. If not news, so if there were no news for that stock, then we're gonna kind of fail it out. So if not news, I think you have a dot. Not yet. Then colon. Next line, we're gonna do return. And then we're gonna return a dictionary, which is gonna be curly bracket. Circle bracket is a tuple. Enter. String ticker. So quotation marks ticker, ticker, not sticker. Colon, great job, ticker, which is our function argument, comma. Next line is going to be articles count string. Yep, 0. Comma, overall sentiment, string. You'll do overall underscore sentiment. Same for articles underscore count. Yep. And then it's going to be a string, all caps neutral. So neutral is in line 2022, Neutral. Yep. Next line, average underscore compound is 0.0. Next line, articles is just the empty list, so a square bracket. Yep, good job. Next line, we're not going to do another dictionary, but outside the dictionary, next line. Adam's here. One sec. Okay. Hello, Adam. So, where were we? Scored underscore articles is also going to be an empty list. So equals a square bracket. Next line, you're going to do compounds equal equals empty list again. Yep. And then you're going to do for article in use. Yep. For article in use. News. News. Next line, S equals score underscore headline. And then it's a function. So do a circle bracket. Then do article, square bracket, articles, because you set it to for articles in use. Yep. And then do a string title. So a quotation title. Next line, we'll do compounds dot append. And then that's a function. We're gonna do S square bracket string compound. Next line, you're gonna do scored underscore articles dot append. And that's a function. Uh, you know, and I'll do it from here because it's just a dictionary anyways. So it's gonna be a dictionary. Inside the dictionary, we have the title. We have the title set to articles title and publisher set to articles publisher. So articles is basically one article in the news. You remember how news we set the limit to 10? Then basically every time okay, you can stop sharing. Let me open mine. So you guys see here, we set news. We want to fetch for news for sentiment. We set the limit here, which is 10. So it's going to give us 10 news in this article. Now, if not news, then we're going to return some empty string. Here we're returning a dictionary. We're going to say there's no article. Therefore, it's neutral. Therefore, there's nothing. No articles. Next, if there is an article, then we're going to do a for loop through the news for each article. The score headline will be whatever score is given by the news's title, which is giving us a score, like a sentiment score of the head, like the title of the article. And then we're gonna do append this one article. We're gonna have 10 in total. And it's gonna be the title, the publisher, sentiment, which is the sentiment that we're going to get from this, and the positive, negative, neutral scores. Understand? So then next, Adam. Adam, can you share? Oh, wait. I should probably give you the my show link. Adam, for you, the live share link is in the chat. Actually, Adam, were you the one who couldn't do it on VS Code? I'll give the link. Or can you? Mm, okay, can't see the screen. If not, then I'll just get push. Oh, you can do it. Okay. I believe something will pop out in the bottom right. Yep, continue as anonymous. Accepted. Okay. So if you go down to line 2051. Yep, right there. So, okay. I think just enter, backspace. Yep, I think it's over there. So average underscore compound equals sum function compounds. Yep, divided by len function. Sorry. Outside the function, you're gonna do divided by len function. Yep, len function. Inside that function, we're gonna pass in compounds again. And then you're gonna do to the right side, you're gonna do if compounds, else zero. Yep. So basically, the average compound will be if it is if compound if there is a compounds, then we're gonna get the sum of all the compounds divided by how many compounds we have. That's how we get average, right? And then if there is no compounds, then we're just gonna set it to zero. Next time, you're gonna do positive count, so positive underscore count. So notice how your screen is going up and back. I think you have to go to bottom right, live share link, but it's gonna be the black one, not the blue one. Not that one, not that one. Above it. You know where the outline, timeline, live share? That live share link. Yep. And then you're gonna do right click on NDJB, and that should be good. Now it shouldn't be jumping back and forth. Okay. Positive count equals sum function one for loop for one space for. No, one space for. C in compounds if C is greater than 0.05. That was great. Great job. And I noticed that now you're starting to get the hang of it, right? You notice that this is an inline function. So basically, this is an inline for loop inside the sum function. So basically, for each C in compounds, we're going to do 1 if C is greater than 0.05. So what's going to happen is if we have like 10 compounds that are like bigger than 0.05, let's say it's like 0.5, all of them are 0.5, there's going to be 1, comma, 1, comma, 1, comma, 10 times. Then it's going to be treated as a list or a tuple of 10 ones, and it's going to pass it through the sum function, which will sum it up and do like 10. All right. So it's going to count how many positive we have, positive like score. Okay. Tab, you're going to do neg underscore count for negative count, or actually you can just do negative count, or up to you. Okay. Space equals space sum, same thing, but same sum function, one for C in compounds if, great job, if C is less than negative 0.05. So if it is a less or like a negative number, then we're going to add it up and see that there's 10 negative kind of compounds. Okay? Next line, we're going to do neutral count. Neutral is going to be between negative 0.5 and 0.5. So what's this? So you can do a sum, but a better way would be just doing len function and pass in compounds minus positive count minus negative count. Sorry, outside this. Compounds minus positive count. Great job. Minus neg underscore count. Yeah, great job. So, no S. So backspace 1. Yeah. So basically, the neutral count is going to be how many compounds we have in total minus all the positive counts minus all the positive negative counts. Enter. Okay. Go to line 2029, 2029, and copy that dictionary, not the return. You're gonna need that first square bracket, curly bracket. Yeah, copy it. And then once you're copied, go down to where we were. We're gonna do next line. You're gonna do return that. Yep. And then for articles count, you're going to do instead of 0, you're going to do len function. Sorry, not there. In the dictionary for articles count. Len function. No, delete the 0. And then pass in scored underscore articles. 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 No P. No P. But S. Yep. And then overall sentiment is not going to be neutral. So delete neutral. Let's also delete the string. You're going to do underscore sentiment underscore label. And that's a function. You're going to pass in average underscore compound. So what's this going to do? It's going to take the average compound and it's going to determine the overall sentiment. So the average sentiment. For average compound, you're not going to do 0.0. You're going to do round function. You're going to pass in average underscore compound. Yep. And then you're going to do comma 4. What this means, we're going to round the average compound to a decimal place 4. So 4 decimal places. We're going to round to that. Now, articles will do not a list. We'll do uh you got the closing bracket, you got to delete, yep. So scored underscore articles. Yep, good job. And then let me do one more. Do you mind saving your Control S? Why is it still white? Hmm. What the? It says starting collaboration session. Failed to save, unable to write file. Okay, maybe just, yeah, stop sharing. And I'll just, hmm, I'll just replace it. Okay, now analyze something. Fetch news for statement is next. So James, can you share your screen whenever you're ready? Let me into Leisure Plus. Accepted. go down. I guess I already have. Okay. So we already did fetch news for sentiment. Okay. Then we'll do sentiment label. So it's just going to be a big for if statement. I mean, multiple if statement. If compound is greater than or equal to 0.35, then colon, return a string called bullish. String. So quotation, bullish. Yep. And then, okay, your thing is going back and forth. I think you'll have to go to bottom left. You'll see outline, timeline, live share. Click on live share. You'll see Andy JB. Right click on it. Yep. Then it should be good. Elif compound is greater than 0.01. I mean, compound is greater than or equal to 0.1. Then we're going to say return slightly bullish. Next, compound is less than or equal to 0.0. I mean, negative 0.0, negative 0.35. Yep. And then elif, I mean, sorry, return bearish. Yes, less than or equal to. So we're going to do bearish and then next line and good job checking as well. Compound is less than or equal to negative 0.1 is return slightly bearish. Yep. And then return neutral. Yep. Good job. So basically, in stock market, there's two kind of sayings, bullish and bearish. Bullish basically means it's doing good, stock is going up. Bearish basically means the opposite, stock is doing bad, everyone's sad. Okay, now I believe models is done. Can you just control S? Okay, now it should be saved. Okay, good. Let's do technical correlation. Give me a sec, James. I'm gonna see what we should do next. I don't know. Let me know if you guys have a preference on which file to work on first. Analysis, correlation, fundamental, risk, technical. Okay, risk would be better. Let's go to risk. So you're gonna do, oh, actually, I'll just open it. You should see it now. No? Okay, go to code, project 13, model, no, analysis, not models. Risk.py. Okay, so basically, this is for risk metrics. So like volatility, value at risk, all these like stock market data. So first, let's do compute returns. Let's read the docstring. We're going to convert a list of prices into a list of daily returns. Each return is going to be whatever the return, I mean, the price was right now. Okay. Return is going to be whatever the price was right now minus whatever the price was yesterday, divided by the price yesterday. And the result has one fewer element than the input. Okay, let's do it. Okay, if length of prices, if len function prices is less than 2, then we're going to do return an empty list. So just square bracket, enter, or else we're going to do, should I do you guys want to do one? Let's just do one. Okay, let's just do a for loop then. For I in range of 1 comma length of prices. That was good. Length of prices. Then we're gonna do square bracket. Actually, before the for loop, we're gonna do prices equals prices underscore equals empty list. And then inside the for loop, we're gonna do prices underscore dot append. We're gonna append empty list. Inside that empty list, we're gonna have circle bracket. Wait. Okay, okay. Delete that line. Delete that line. And then let's do prices current. Prices underscore current equals circle bracket prices I minus to the right prices I my prices I minus prices I minus 1. Yep. And then you're outside the circle bracket, you're gonna do divided by prices square bracket I minus 1. Okay, that's good. No, 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 not that, not that. Remove that part. So prices I minus prices I minus 1 divided by prices I minus 1. That's good. And then you're gonna do prices underscore dot append prices current. Yep. Enter backspace in the same line as for return prices underscore. Yep, that's good. And you can stop here. Thank you, James. Save the file. Control S. Thank you. Compute returns is done. Then, Caden, can you share your screen? One sec. Okay, Caden. You might have to make it wider. It's like a square right now. Okay, it changed. Okay, now we're going to the second function, which is annualized volatility. And you will know what volatility is. No. So volatility is basically, oh, it says here, compute this, basically the standard deviation of the returns multiplied by the square root of trading days. Return as a percentage. So basically volatility basically means how much the stock prices change in a way. So if it's like constantly going up or like constantly going down or like there's not many change or ways, then volatility will be just small. But when your stock market one day goes all the way down, the next day goes all the way up and just constantly goes weird, that's when the annualized volatility is skyrocketing. So why this matters? People basically use it to like measure or kind of tell how unsure or sure people are at how the state of the market is right now. So like they're confident that the people are not worried at all. But if people get worried, then the stock prices kind of change quickly. So let's do this. We're gonna do if length of returns. So if len function returns is less than 2, then return 0.0. Next line, return 0.0. Yep. So our analyzed volatility has two arguments. One is returns, which is a list of float, and trading days, which is an integer, which is by default 252. So what we're going to do is return round function np.std. std stands for standard deviation. Standard deviation you guys will learn in stats class, I think, or yeah, and then probabilities class, right? I hated probabilities class. Anyways, standard deviation is, I believe, I forgot everything. Okay, standard deviation of returns, comma, inside the function, you're going to do returns, comma, DDOF equals 1. Okay, and then still inside that round function, but to the right, you're going to do times or asterisks. Yep, math dot sqrt for square root. And that's a function. You're going to pass in trading underscore days. To the right, but still in the round function, you're going to do times 100. Outside the square root function. Comma 2. Yep, like that. Okay, so basically what we're doing, we're going to use NumPy's standard deviation to get the standard deviation of the returns. We're going to then multiply it by square root of the number of trading days. And then we're going to get the percentage of this by multiplying by 100. Then we're going to use the round function to get to round this number to 2 decimal places. All right? And this is going to be our annualized volatility. And I believe it's default 252 trading days because that's the number of trading days the American stock market has. So like excluding Saturday, Sunday, excluding some holidays. Okay. Now, where am I? I think we can do another one, right? Okay. So value at risk. Basically, let's read the doctrine. Calculate the value at risk at a given confidence level. Use percentile to find the return at -1 minus confidence percentile. Return the result as a percentage. So you guys will learn confidence and percentile in stats and probabilities. I hated those classes. So yeah. So you're gonna do if length of returns is less than 2, less than. If length of returns is less than 2. Opposite. Yeah. Return 0.0. Why is there a lag here? I don't get it. Okay, but return 0.0. Yeah. Next line, we're gonna do return round function. Inside the round function, we're gonna do np dot percentile, which is a function. We're gonna pass in into the percentile function returns, comma, tuple, so a circle bracket inside the circle bracket, 1 minus confidence outside one circle bracket times 100 outside the other circle bracket times 100, comma 2. So what are we doing here? We're getting the 1 minus confidence times 100. And then we're gonna do the, okay, so let's say confidence level is 5 or 0.05. That means if it is in that 0.05 section, then we're gonna be confident about this result. All right? So 1 minus 0.05, 0.05 is 0.95 times 100 is 95, right? So we're gonna get the 95th percentile of this returns. Make sense? Now with that 95th percentile, we're gonna multiply it by 100 and round it by 2. And this gives us the value at risk at this given confidence level. This is something you learn in like stats. And confidence level is usually used when you do like hypothesis proving. So if you're in that like 5 percentile of confidence, then only then are you gonna like accept the hypothesis as true. And you can stop sharing. Adam, can you share your screen when you're ready? Okay. Mm, okay, I think reload. That shouldn't even be the file this. Oh, you have to, okay. Accept. Risk.py. Yep. Okay. You're gonna go down to conditional underscore var. I believe it's line 29. No, 41. Uh, actually, 53. Okay, so we're gonna get the calculate the conditional variance. Var means variance. All right. So variance is gonna be the expected shortfall. We're gonna yeah, right click on that. Go down to 53. Go down. 53. We're gonna find the variance threshold, then average all the returns, and return the result as a percentage. So delete the pass. You're gonna do if delete the pass. If len function pass in returns s is less than 2, colon, enter, return 0.0, enter, backspace, variance or VAR equals np dot percentile function returns comma circle bracket 1 minus confidence outside this one circle bracket times 100. So asterisk 100. Next line, tail equals empty list, where inside that list we're gonna do R for loop 4 space R in returns if R is less than or equal to var. You see that if, yeah, that's good. Great job. Next line, if not tail, colon, return 0.0. Okay. Enter backspace. You're going to return round function. Pass in np.mean function tail. To the right of that circle, yeah, times 100, comma 2. Okay, so variance is we're getting variance by doing np.percentile. We're passing in returns, comma 1 minus confidence times 100. So we're getting the kind of like, let's say if confidence is 0.05 again, We're getting the 95th percentile of the returns. We're going to set the tail for every value that is less than variance. And then we're going to do if there is no like nothing that's less than or equal to variance, then return the conditional variance is 0, or else we're going to round it to 2 decimal places. Okay? You can stop sharing. James, can you share your screen? Yep, no worries. Mm. Accepted. And then we're going to do maximum drawdown. Delete the pass. Yep. Okay. If length function of prices, not function, prices is less than 2, colon, return 0.0. Enter, backspace, peak equals prices, square bracket 0. So we're going to index it to get the first price. We're going to do max underscore dd equals 0.0. Max dd means maximum drawdown. All right, I forgot to explain the function. We're going to compute the maximum percentage drawdown from a peak. Peak meaning the highest like stock price. We're going to track the highest price seen. At each point, we're going to calculate the peak minus the current divided by the peak. And we're going to keep the maximum value and return it as a percentage. Okay. For P in prices, if P is greater than peak, peak equals P. DD equals circle bracket peak minus P divided by peak. If and if DD is greater than max underscore DD, then max underscore DD equals DD. Enter. Great job. And backspace. Yep, great job. Return round function max underscore DD times 100, comma 2. And that's it. Okay. Kaden, can you share your screen when you're ready? You're gonna do all the way down to line 92. Sharp ratio. So compute the Sharp ratio, which is kind of like a stat. My bad, oh, that's fine, Kaden. Use np.mean, so we're gonna get the average of the returns and multiply it by trading days for our annualized return. Okay, so do if len function of returns is less than 2, colon, enter, return 0.0, excess, excess, equals np dot mean function returns. To the right, you're going to do times trading days minus risk-free rate. Next line, volatility vol equals, sorry, vol as in VOL, VOL equals np.std for standard deviation, returns, comma, DDOF equals 1. To the right, you're going to do times math.square root. So math.sqrt function, you're going to pass in trading underscore days. Next line, you're going to do return round function excess excs or excess divided by vol as in volatility comma 2. Now to the right side, you're going to do if vol does not equal 0. Great job. Else 0.0. Great job. You can stop sharing. Adam, can you start sharing your screen again? When you're ready. Next, we're going to do Sortino ratio, which is going to be line 110. How come we always round it to 2? Well, in this project, it was because I chose. But I don't know. People usually round it to 2, but I have no reason why. Maybe 1 is too little and 2 is just right. But yeah, it was just my choice. You guys can change it too. Where were we? Sortino ratio. So basically, we're going to compute this ratio, which is another kind of value, which is like the Sharp ratio, but only penalty is that negative volatility is penalized and filter returns to only negative values and compute their standard deviation. So delete the pass on line 121. And then do if len function pass in returns is less than 2, colon, return 0.0. Enter backspace excess EXCESS equals NP dot mean function returns to the right times trading underscore days minus days minus risk free rate risk underscore free underscore rate. Delete the days. Great job. Next line. Next line. Downside. Downside equals a list, which is square bracket, R for loop 4, R for, okay, R for R in returns if R is less than 0. Next line, if not downside, colon, return 0.0. Next line, backspace downside underscore vol, VOL, no, downside underscore VOL. V, volatility V. Yep. Equals np.std dd function. Sorry, need a drink of water. Downside, comma DDOF equals 1. To the right, you're going to do times math.sqrt function. You're going to do pass in trading underscore days. Next line, you're going to do return round function excess EXCESS divided by downside underscore vol, comma 2. To the right, you're going to do if downside underscore vol does not equal 0, else 0.0. And that's it. You can stop sharing. I think that's it for today. Let's go to Blinkit. Hmm. There's a new Spider-Man movie out. Maybe we can do this. Flashing Frenzy. Link is in the chat. Oh, while we wait, let me stop recording.